before we got onto this podcast, before we started, you guys were talking about spindles.
Yeah.
Let's
Good.
go down the spindle rabbit hole. What's a spindle?
Yeah. So I don't know if you want to tackle it or I can jump in. I mean, so a spindle differs from what we've been talking about so far in the fact that an operator is not going to hold a spindle. I've had operators try to tell me, yeah, we can run this thing. Well, typically there's no trigger on a spindle, so there's no way for the operator to hold it. You're going to find a true spindle in more of an automated fixtured application, whether it be a multi-spindle or single spindle application. Prime example for a multi-spindle are wheel nuts. You see it all the time, whether it be 4, 8, 10, whatever it is. You'll have a multi-spindle end effector, for lack of a better term, that has 8 spindles on it, and you're running all 8 wheel nuts at the same time.
So you're like, wheel goes up.
Yep.
This comes in and it's got, let's say, 5 right here.
Yeah.
I had to look. Wheel goes up and it puts all 5 in at one time, and then it moves back here and does this, or they might have 2 that go on at one side, flip it over, and do 2 more, whatever. All right, that makes sense.
And that's just one example. Anthony could probably touch on a multiple, wide range of different examples. But
And it could be any configuration too. You know, you could, if you were putting a panel on something, you know, if this was something that needed to be attached to something, it's a square and you needed 4 bolts, maybe 1 in the center, whatever.
Yeah.
It just goes up and you're doing all 5 of them, 4 of them, or whatever at one time.
Yeah.
Well, yeah, I think that's a great example, right? The wheel nut is the number one application for sure. But another good one too is like if you have sequencing that's really important. Like if you're trying to set a gasket, right? And you don't want to tighten this down too fast.
Right.
You know, you're squishing it, moving around. So that's another really good application.
And you can lay it in or however you need it to.
And they're synced up, right? They can be synced up and made sure that they're running down the same amount. You know.
I know what a spindle is.
There you go.
Now it says conventional versus intelligent. What's the difference of the two?
That I'll probably need to let Anthony speak to a little bit.
Yeah, so we were talking about servos, and I won't go into that, but basically a conventional spindle, you can only run 1 spindle per controller. Okay. The reason that is because the servo is located on the controller, right? For the intelligent spindle, we actually have a patent on this. It's one of the best spindles in the industry for sure because of this. We've had great success with it. We actually put the servo on board with the spindle, okay? And we can daisy chain the tool. Why does that matter? Basically, again, cost savings, right? You only need 1 controller for multiple spindles, but also space savings for all the cords.
All right.
So now I don't have to run, say I got a 5 lug nut application on a wheel. I can run 1 cord back to 1 controller rather than running 5 cords back to 5 controllers. So space savings, cost savings, obviously time and cable festooning savings. So, yeah.
You talk about, like with a spindle system, there's really no way to go, well, what's the ROI on that? Because in many cases, it's like you couldn't do it.
Yeah.
And, what do you want to do? Have one guy up there with setting the wheel up and then, whatever. And so it's invasive on your physical person, as far as the ergonomic standpoints. You've got issues with time. The spindle just comes in and knocks it out.
Yeah.
So, the overall impact would probably have to be a gargantuan cost savings with the volume that you could just get out the door.
Exactly. Yeah.
Compared to the other way. So it's not even a...
Well, even upfront savings, there's definitely a crossover point where 1 or 2 spindles might not be advantageous on a intelligent spindle.
Yeah.
But once you hit 3, 4, 5,
I would say 4 is probably the limit.
Yeah, I mean,
kind of the cutoff point there.
You actually see an instant cost savings. Yeah. So it's a real instant. And
so I'm thinking, with the wheel thing, you're thinking a really big application. they can probably be done in smaller applications too, where you just need repeatability, fast, and production oriented moving.
Absolutely.
You know what I mean?
We've done applications as small four spindles, true four spindles, as small as maybe a 4-inch square pattern.
Okay.
So you can get them tight, and especially with the intelligent spindles, the Series 1, I believe we can get the size on those spindles as long as the torque fits the tool.
Was it on some kind of a line where parts are moving down through?
So it's on a line where the operator's feeding parts into a fixture, and they
Okay.
slide it in, and then it comes down and hits it.
Wow.
And then moves on out. So
Boy, talk about speeding up the
yeah. So
assembly process.
the ergonomic and toll on the operator is just right off the bat what you see as far as the advantages of doing something like that. Where the math comes into play a little bit more, and you mentioned ROI, is the speed. How much does this speed up our productivity? How much more product can we get out the door, just like you said? And that's where we focus on trying to help the customer prove out their ROI and justify the investment.
And I know you guys have very detailed ways of doing that. I've seen you
Yeah.
guys sitting down, kind of hammering out the board
Yeah.
in the assembly.
It's all
Office.
about time and product movement.
Moving that delta.
Yeah, exactly.